Sample problem. Two equal positive point charges of magnitude plus 5 microcoulomb are on the x-axis. One is at the origin and the other at x equals 8 cm as shown in the figure below. Find the electric potential at a point P1 on the x-axis at x equals 4 cm and b point P2 on the y-axis at y equals 6 cm. Letter A. First we solve for the electric potential at point 1 as shown on the figure. We see that all the quantities are just on the x-axis. To solve for the total electric voltage we just sum the charges algebraically, which means we ignore the direction since electric potential is a scalar quantity. So we write the formula and manipulate it and take into consideration the value and unit of the constants. One strategy to determine if you have arrived at a correct solution is by examining the units. For this case we see that the units will cancel some of them and end up with the joules per coulomb, and we know that this value will lead to the unit volts. This is called dimensional analysis. So here we see that the value for the electric potential when two like charges are equidistant from the point 1 is equal to 4.95 times 10 to the power of 6 volts. Letter B. Next we solve for the electric potential at point 2 as shown on the figure. We see that they are different distances. So we use the same equation to obtain the total electric potential as shown by equation 13. So we substitute and manipulate the equation and we get that the total voltage is shown here. This is again confirmed by its units using dimensional analysis.